Aloha, this is Michael Baisa. I'm going through my CIT 260 final presentation for the semester based off of the work that we did for our Save the Village project. First thing I wanted to share is in regards to static and non-static. First of all, with variables. Non-static variables, when you create an instance of a non-static variable in a class or in a function, that variable only lasts until the end of the class or the function, and then it is destroyed. But if you make that variable static, every time that you go back to that class or to that function, the variable that's there remains there, and it holds the values from previously. Hence, it's static. It remains the same. Or it remains in memory to be used and updated again. So in our Save the Village main function, or right above the main function, we have a number of static variables that'll stay the same whenever they're called. Between static functions and non-static functions, we have the difference of static functions are required to have all static variables. There cannot be any variable that's not static in there. So if you were to look through this, all of these variables that are listed in here are static variables. And you are, the advantage of static functions is that you do not need to instantiate a class in order to call them. So this wouldn't happen with main, but if I wanted to call, if this were another function that was static in Save the Village, instead of doing Save the Village equal, Save the Village variable name equals new Save the Village function such and such, you would just be able to go save the village dot function name, and you would be able to access that function a lot faster and easier. And that's one of the primary uses of static functions versus non-static. Although when you're passing around a lot of data, a lot of classes, most likely you will be using static functions. Now, next up, we have the difference between the three main list types, your array list, your array, and your enum. I'll start off with the array list. Array list, which we really didn't use in our program, we didn't have a use for it, is basically a listing of different kinds of items, objects, primitives in a list. These can be any different kind of things. You can mix and match, and that's good with an array list. And array lists are not fixed length. You can add to, remove from. Enumerations, on the other hand, are fixed, and we have an example of an enumeration with our item class. They're fixed once they're created, so this default constructor runs, and with all of these different variable settings for the class. This item class, once everything is set up here, that's fixed. You cannot add to, you cannot change, you cannot remove from. But these are essentially constants, constant class that you can call for whatever data is stored inside a particular item. Arrays are, you could say, in between, and arrays are fixed length, but they but you have the ability with an array to change whatever is in an array. And going to this example, we created a list of NPCs, non-player characters, in this function. We created each NPC here, and over in this section of the code, we are assigning those NPCs to a particular spot in the array that we created. Now, if I wanted to, I could come back later and say I wanted to switch Edgar and Lucy in the spot listings, I could do that, and that would be perfectly fine. But I would not be able to add additional NPCs once this NPC array has already been created. Going on, we want to go through how to use a for loop in order to assign or access information from an array. So in this next part, which follows, we're trying to assign those NPCs that we created in that array. We're trying to put them into different scenes in the town as a part of our map. So the for loop works where we start, in this case, we start with a 0, which is the base index for all arrays. And then we go through the length of the array list, so npc list.length, and then we're incrementing by 1. And then it'll loop through each of those NPCs. And in the case of this function, we're going to generate a random number to basically decide where on the map we're going to put the NPC. And then once that number has been decided, then we take the NPC and we put that NPC into a specific scene. And thus we are able to place all NPCs on our map. Next up, I wanted to talk about throwing, propagating custom runtime errors, and we have a couple of classes for that. I'm going to start with the communications view. So in this view, there's a part where we're trying to validate the NPC right here, make sure that the NPC we were talking to is an actual NPC and not a typo or an NPC that doesn't exist. So because this says the potential to return errors, we're going to surround it in a try catch block. Here we have the catch for the error. And then the actual testing is going to come from the scene control, this validate NPC. And as you can see at the end of the function signature, there's a throws clause with our custom exception class. And basically, we go through the list of NPCs at a given scene and try and match the name up. If none of them match, then we know that that NPC doesn't exist, and we will throw a new scene control exception with this error message in the default constructor, or in the non-default constructor that takes a string. And then that error is thrown back to this catch, which then takes that error and displays the error message to the user to let them know what happened. And that's our custom error class. Next, I wanted to go over the difference between character streams and byte streams, and then talk about reading or writing data to an external file. So byte streams are actually quite handy. They don't take as much work. Well, they don't take as much as a character stream class because they are, byte stream is based on the ASCII character set. Which for a lot of intents and purposes is all you really need. However, when you're dealing a lot with objects, when you're dealing a lot with foreign languages, or when you're dealing with other things that require Unicode, byte streams cannot cut it. You have to use character streams. And character streams are actually quite handy. They're the recommended stream output and input to use when dealing with files, keyboard input, screen output, stuff like that. They're recommended because they're so versatile. So in this function, we take a look also at the file input output. Now this output uses character streams. This print writer is a character stream class. So we create an instance of the character stream class, After we prompted the user for a file name, it takes that default. It takes that non-default constructor and uses the file name to open a file. An important thing about file input output is you always have to remember to test the file or try catch for errors, which can be common with files. And you also have to remember to close the file when you're done. This format, the try with resources, is a handy way to make sure that the file is closed. If you use this format, it'll automatically check and make sure that the file is closed once you're done with that function. So you do that and it creates the output file. And then using the character class functions, you're able to use like printline, printf, and you can use those to print out a report. In this case, it's a report of all of the various statistics that the player has currently. And then, of course, if any errors were to happen with the file or anything else, that would be caught, and then that would be displayed to the user. Aside from that, all I've got to do is give a brief demonstration of our game. So we are going to take a look at that. So here's our opening scene with the main menu. I'm going to start a new game and type in my name. Choose a race. I'll be human. I'll say my age is 32, which it's not. And then we start on the map, on the forest map. I don't have much money, so I'm going to go out into the forest, which in this case is out to the west. And then you can move around with northeast, southwest. And then when you're in a scene, you can search using X. In this case, since you've just found the dungeon, that's actually an enter dungeon. But if you wanted to try to enter the dungeon, you notice that there you don't have a key yet. So one of the goals is you have to find the key in order to enter the dungeon. And then you can fight the boss and save the village. So we're going around here. If you press X to search, there's nothing there. And then there's random battle encounters. So in this case, giant enemy spider. This is your battle menu: attack, magic, use item, run away. For time's sake, I'm going to use magic and use this cool spell called Fire Burst, which does a lot of damage and destroys the enemy. And then I can keep the gold that I find. And I'm going to go back to town. Okay, magic, Fire Burst. Okay, now I'm on row 2, column 5. So when I go west, I run out of mana if I keep on doing this. And okay, keep on doing that. And we made it back to town. So in town, you can find clues from NPCs that are in there. So I'm going to type in a name. And this person gives a clue, says there's something out west. So we can go out to the west and find it. And basically you go through, you find a dungeon key, you go and you fight the boss, and you save the village, but you have to do it within a specific time frame. And that is the premise of the game. Hope you enjoyed the presentation. Thank you so much, and have a good night.